Download this code from codegive.com, link in the description below. OK, let's embark on a comprehensive journey of deploying Kubernetes to AWS using EKS, Elastic Kubernetes Service. This will be a detailed, step-by-step guide with code examples, considerations, and best practices. EKS 101, Deploying Kubernetes on AWS. 1. Understanding the landscape, Kubernetes, AWS, and EKS. Kubernetes, K8s, an open-source container orchestration system for automating application deployment, scaling, and management. It abstracts away the complexities of managing individual containers, providing a declarative approach to defining desired states. AWS, Amazon Web Services, a comprehensive cloud computing platform offering a vast array of services, including compute, storage, networking, databases, and more. EKS, Elastic Kubernetes Service, AWS's managed Kubernetes service. EKS simplifies the process of running Kubernetes by handling the control plane management, security patching, and scaling of the Kubernetes master nodes. You are responsible for worker nodes. Key benefits of EKS **** Managed Control Plane **** AWS manages the Kubernetes control plane, API server, scheduler, controller manager, ACT, reducing operational overhead. Security * integration with AWS IAM for authentication and authorization, and automatic security patching. Integration * seamless integration with other AWS services, EC2, VPC, IAM, load balancers, EBS, etc. Scalability * easily scale your Kubernetes cluster up or down based on demand. AWS certified * meets Kubernetes conformance standards. 2. Prerequisites. Before you begin, make sure you have the following installed and configured. AWS account * an active AWS account with appropriate permissions to create and manage resources. AWS CLI * the AWS command line interface. Install and configure it with your AWS credentials. Verify it is installed, AWS version. Kubectl * the Kubernetes command line tool. Install and configure it to interact with your EKS cluster. Verify it is installed, Kubectl version client. ***, a command line tool specifically for creating and managing EKS clusters. This makes cluster creation much easier. Install and configure, follow instructions on the weaveworks/exckl GitHub page. Verify it is installed, exckl version. IAM user configuration * ensure the IAM user you are using has the following permissions, ideally, use an IAM role instead for enhanced security. Amazon EKS cluster policy. Amazon EKS CNI policy. Amazon EKS worker node policy. Amazon EC2 full access, needed to create the required EC2 instance for the cluster. IAM full access, needed to create the required IAM role for the cluster. VPC full access, needed to create the VPC for the cluster. Terraform, optional while exckl is highly recommended for simplicity, using Terraform provides more granular control and infrastructure as code benefits. We will include a basic example later. Helm, optional a package manager for Kubernetes. Useful for deploying complex applications. 3. Setting up your environment. Configure AWS CLI *. Enter your AWS access key ID, secret access key, default region name, example US West 2, and default output format, example JSON. Asterisk verify kubectl configuration asterisk. Initially, it will likely show no context. This is normal, as you haven't created any Kubernetes clusters yet. 4. Creating an EKS cluster with xctl, recommended. Xctl greatly simplifies EKS cluster creation. Asterisk create a cluster definition file, cluster.yaml. Asterisk explanation asterisk. Asterisk API version, specifies the API version for the xctl configuration. Asterisk kind, specifies the resource type, which is cluster config in this case. Asterisk metadata.name, the name of your EKS cluster. Choose a descriptive name. Asterisk metadata.region, the AWS region where you want to create the cluster. Asterisk node groups, defines the configuration for the worker nodes. Asterisk name, the name of the node group. Asterisk instance type, the EC2 instance type to use for the worker nodes. T3.medium is a good starting point for testing. Asterisk desired capacity, the initial number of worker nodes. Asterisk min size, the minimum number of worker nodes. Asterisk max size, the maximum number of worker nodes. EKS will automatically scale the number of worker nodes between min size and max size. Asterisk private networking, makes the cluster private. Asterisk availability zones, lists the availability zones where the worker nodes will be deployed. Spreading worker nodes across multiple AZs provides high availability. Asterisk create the cluster asterisk. This command will 1. Create a VPC, virtual private cloud, if one doesn't already exist with the necessary networking configuration. 2. Create the EKS control plane, Kubernetes master nodes. 3. Create the worker nodes based on your cluster.yaml configuration. 4. Configure kubectl to connect to your new cluster. The cluster creation process can take 15 to 30 minutes. Xctl will print progress updates to the console. Asterisk verify the cluster asterisk. You should see the worker nodes listed. Their status should be ready. Asterisk get cluster info asterisk. This will display information about your cluster, including the name, region, and status. 5. Alternative, creating an EKS cluster with Terraform, more granular control. Terraform allows you to define and manage your infrastructure as code. This provides better version control, reproducibility, and consistency. Asterisk create a Terraform configuration, main.tf. Asterisk explanation asterisk. Asterisk provider configuration asterisk defines the AWS provider and region. Asterisk VPC and subnets asterisk creates a VPC with public subnets for the EKS cluster. The VPC and subnets will be used to host the EKS control plane and worker nodes. You can adapt this to use existing VPCs and subnets. Asterisk Internet Gateway and Route Table asterisk creates an Internet Gateway and Route Table to allow outbound Internet access from the public subnets. Asterisk EKS cluster asterisk defines the EKS cluster, including the cluster name, IAM role, Kubernetes version, and VPC configuration. Asterisk IAM roles asterisk creates the IAM roles required for the EKS cluster and worker nodes. These roles grant the necessary permissions to access AWS resources. Asterisk security groups asterisk defines security groups to control traffic to and from the EKS cluster and worker nodes. Asterisk node group asterisk create node group. Asterisk outputs provide useful information, such as the cluster endpoint and kubeconfig. The kubeconfig is used to configure kubectl to connect to the cluster. Asterisk initialize Terraform asterisk. Asterisk plan the infrastructure asterisk. This will show you the changes that Terraform will make to your AWS infrastructure. Apply the configuration *. Type yes when prompted to confirm the changes. The Terraform apply process can take a significant amount of time, similar to xtl. Configure kubectl*. After the Terraform apply is complete, you need to configure kubectl to connect to your new cluster. This is normally done in xtl automatically. With Terraform, you need to manually configure this. Use the output from Terraform. Verify the cluster *. You should see the worker nodes listed. Their status should be ready. 6. Deploying a sample application. Let's deploy a simple Nginx web server to your EKS cluster. Create a deployment, Nginx deployment.yaml. Create a service, Nginx service.yaml. Explanation deployment defines how to deploy the Nginx container, including the number of replicas, instances, the container image, and the ports to expose. Service creates a load balancer service that exposes the Nginx deployment to the outside world. AWS will automatically provision an elastic load balancer, ELB, and configure it to route traffic to the Nginx pods. Apply the deployment and service verify the deployment The Nginx deployment should have the desired number of replicas running. Verify the service The Nginx service should have an external IP assigned to it. This is the DNS name of the load balancer. It may take a few minutes for the external IP to become available. Access the application Open a web browser and navigate to the external IP of the Nginx service. You should see the default Nginx welcome page. 7. Scaling your application. Scale the deployment This will increase the number of Nginx replicas to 4. Kubernetes will automatically launch new pods to meet the desired replica count. Horizontal pod auto-scaling, HPA. To automatically scale your application based on resource utilization, you can use horizontal pod auto-scaling, HPA. This will create an HPA that scales the Nginx deployment between 2 and 10 replicas based on CPU utilization. The HPA will attempt to maintain an average CPU utilization of 50%. 8. Cleaning up. When you are finished with your EKS cluster, it's important to clean up the resources to avoid incurring unnecessary charges. Delete the EKS cluster, using xtl. Delete the Terraform infrastructure Type yes when prompted to confirm the deletion. Important considerations and best practices security use IAM roles for both the EKS cluster and worker nodes to grant the least privilege necessary. Enable Kubernetes RBAC, role-based access control, to control access to Kubernetes resources. Use network policies to restrict traffic between pods. Regularly update your Kubernetes version and worker node AMOS to address security vulnerabilities. Networking consider using a CNI, container network interface, plugin like Calico or Cilium for advanced networking features. Use network policies to control traffic between pods. Monitoring and logging use Prometheus and Grafana to monitor your Kubernetes cluster and applications. Use Fluent or Elasticsearch to collect and analyze logs. Enable Kubernetes control plane logs for auditing and troubleshooting. Storage use EBS volumes for persistent storage. Consider using a CSI, container storage interface, driver for more advanced storage features. Cost optimization *. Choose the appropriate EC2 instance types for your worker nodes. Use spot instances to reduce the cost of worker nodes. Right size your deployments and services to avoid over-provisioning resources. High availability deploy worker nodes across multiple availability zones. Use pod anti-affinity to prevent pods from being scheduled on the same node. Configure health checks for your deployments and services. Infrastructure as code *. Use Terraform or CloudFormation to manage your EKS infrastructure. This makes it easier to reproduce your environment and manage changes. Kubectl context *. Always make sure your kubectl context is set to the correct cluster before running commands. Advanced topics, beyond 101. Service Mesh, Istio, Linkerd provides advanced traffic management, security, and observability features. GitOps, Argo CD, Flux uses Git as the source of truth for your Kubernetes deployments. CI/CD pipelines * automates the process of building, testing, and deploying your applications. EKS add-ons EKS provides managed add-ons like CoreDNS, VPC CNI, Kubeproxy, and AWS EBS CSI driver. EKS Fargate serverless compute option for running containers. You don't manage the underlying EC2 instances. This tutorial has provided a comprehensive overview of deploying Kubernetes to AWS using EKS. Remember to adapt these examples to your specific needs and environment. By understanding the core concepts and following best practices, you can successfully leverage EKS to build and manage scalable and resilient containerized applications in the cloud. Good luck.